national program of research, development and extension that spans each of Australia's plant industries. We're doing research and development into new technologies for surveillance and diagnostics. With the Sentinels here, we have developed new technology and world-first automation of some of these traps. So we have an onboard spore sampler and a 6-metre insect suction trap on this unit here and a 2-metre insect suction trap, and they're all housed in the same unit, and we're exploring how they operate together and how that relates to what we're seeing out in the crops as well. Then there's the diagnostics side of things. There's some novel diagnostics technology that's been developed, and we're able to screen samples for a whole range of targets. We're also able to apply similar technologies to understanding what insects are feeding on.
We've now developed a system that is really drawing from lithium-ion batteries and solar panels and can sustain itself. And the automation itself needs to be just really robust. It's got to deal with extremes. There's been quite a few ways we've been able to show the value of pest and disease monitoring. We've been looking at fungal pathogens that affect a range of vegetable crops, whether that's sclerotinia or botrytis pathogens, where they have multiple hosts, so they affect a whole range of horticultural crops as well as grain crops and pulse crops. But also with pests, we've been able to show that the value of monitoring long-distance movement of some pests, but also localised dispersal of other pests. We did discover at that point that the SLM are somewhat lazy flyers when they've got a nice food source right there. And that's when we realised we needed to be trapping from much lower down to understand the movement when they do come out of that crop and move to another. So that's where we're able to sort of quickly adapt a further platform which is able to trap at a couple of different heights. The Sentinels don't just tell you about a pest and disease, it tells you all about the weather conditions associated with that, because it's all linked. And when it's all linked, you can start using that to understand more predictive analysis of that data and forecasting, and as well as informing models themselves, and that's really valuable. Probably the ideal will really be having a network of these Sentinels across a landscape and delivering this end-to-end surveillance in a very automated and systematic way.
And metabarcoding is a technique that allows us to detect hundreds, if not thousands, of insects present in the same sample. You can think of metabarcoding as the classic barcodes you have in a supermarket. So while in the supermarket you can connect a price to a product, we can connect each different insect species to a very specific DNA fragment, and this allows us to connect it to a species name. Metabarcoding is a pretty powerful tool. So depending on the season, depending on the time of the year, you can detect any kind of species that can be of interest, and that is not limited to pests. For example, a healthy crop is a crop that includes also beneficial insects that could be pollinators or parasitoids.